one more time. Got it. Done. Let me get these stragglers. All right, let's see. Got him. Man, we got a lot. I got him. Okay. This one. Okay. ABCD. ABCD. W. ABCD. No, I got him already. Got him as well. I just want to make sure. And H. All right. ABCD. There he is. Okay. Okay. So let's go ahead and share the screen. Hopefully you guys can hear me okay. Right now, I think you can feel free to unmute yourself. So if you're just joining us, we're just getting started. We did have a little bit of a slow start. Is there a way I can change the view? That's okay. So we did have a little bit of a slow start, but we worked out the kinks. Let me see as far as announcements go. So this is like the first official lecture. I think last week it was like orientation. If you didn't get attendance credit on Wednesday, just kind of, I usually stop with like anywhere from 5 to 10 minutes left on the clock, right, at the end of class. So if you didn't get attendance credit, just, bring it to my attention at the end of class. But generally speaking, I don't want you guys stressing too much about attendance. Attendance doesn't affect your grade. I know it shows up in Blackboard, but it doesn't affect your grade. Only way it affects your grade is if you accumulate too many absences, because you can be booted from the course. But it's not directly factored into your grade. So what I was thinking for today and tomorrow or Wednesday, today we'll spend some time on section 1.1. We could go right into the homework. I was going to kind of redo the presentation, but if it's not necessary, if you would rather go through the homework, we can. Again, class time is generally designed to be like a Q&A or a study session, because the presentations I'm going to do now, or the lecture, is already available on my YouTube channel, right? So there's a playlist that already has this. If there aren't requests for like specific questions, then that's when I start going through the lecture. But if you guys want to go through the homework, if you have questions from the homework, now is like the time where we can take some time and look at the homework, right? So I'm just gonna, like I said, I'm just gonna make my way through the lecture, unless you guys have questions from the homework. Okay, so we're gonna start with chapter 1, graphs and functions, in section 1.1, graphs of equations. Some objectives here: we want to plot points in the Cartesian coordinate plane. And stop me if anything is not clear. If you have a question about anything, or you should be able to unmute yourself. Let me check. I'm just going to assume that it's working, and I'll periodically check the chat. The chat looks clear. So yeah, you just have to get my attention. We also want to find the distance between 2 points, find the midpoint. So I want to say the homework for this section was due last night, at midnight. So Sunday night at 11:59 p.m. going into this morning. You can actually work on it past the due date with the 10% late penalty. I think there was a homework assignment and a quiz. Also, as a heads up, so our exam 1 is going to be during week 4, right? Exam 1 is during week 4. And I think there are some prerequisites for exam 1. I think you have to pass quizzes for weeks 1, 2, and 3, right? So you don't want to wait until that exam becomes available and then be trying to work on those quizzes, because it's eating into your precious time, right? So you want to do the best you can to go ahead and pass your quizzes. Hopefully you've already sought out tutors. I do encourage you all to link up and work together, like with a group me or any kind of chat where you guys can ask for help and work together. I encourage it. I think it's a good idea. So some other objectives. So we want to find a distance between 2 points. Also, as you make your way through this material, my recommendation or suggestion is you definitely want to have a notebook. A lot of success in mathematics, or at least for my course and a lot of the courses, is all based on your ability to organize. If you don't keep a record of what you're doing, if you like, you can do some work, and then when you need it, you won't have it as a reference. You may or may not remember it. So the more organized that you can be, the better, right? So the recommendation, you have a notebook where you're taking notes as if you're in class, right? All of this stuff that you see me doing on the screen, I'm going to make a PDF available on Box. The link is in our Blackboard. It's the handouts, the Box link folder. It's going to be in there, but you definitely want to make your own notes. Write down questions, and as you go through the homework questions, get a copy of the original, show all your supporting work, and then have your final answer in the box. It's going to come in handy. If you see it again someplace important and you can have open notes, if you haven't created it yourself, it's not going to serve you. If you have somebody else's note, that's not really going to serve you because you're not going to have an intimate knowledge of what's in there. Like if you're just rummaging through, you'd be better off with the book if you're not going to do it yourself. So, I mean, even if you had somebody else's notes, that's not really going to serve you. The best thing is to make your own and work together. Yeah, that's about all I can think to say there. Oh, and so the reason I was bringing that up, as we come across formulas, I know we're kind of eating into time, but as we come across formulas, you want to have some place in your notebook where you have a formula list, right? Where every time you come across a formula, you update your formula list with all the formulas that you come across. So that would include things like the distance formula, midpoint formula. We're going to also look at sketching a graph by plotting points, finding the intercepts of a graph, finding the symmetries in a graph, and finding the equations of a circle. Another thing about the structure of our course, you're not obligated to stay. This is remote asynchronous. Again, once you've gotten into my Zoom, that means you've gotten your attendance credit for the day. If you need to leave, it's totally okay because I do live stream our sessions to my YouTube, and these lectures are already recorded on my YouTube channel. Okay, so that was enough of the objectives, and I think that was all the announcements I wanted to say. So let's open up with some definitions and what do we mean by an ordered pair of real numbers? It's going to be a pair of real numbers in which the order is specified, right? So, you'll see this a lot if you haven't already seen it. You have the x comma y, where the first component is your x coordinate. On the coordinate axis, the x's run side to side. So negative x is to the left, positive x is to the right. The second component is your y component. It runs up and down. So positive y is typically going up, negative y is typically going down. So these are the coordinates, the location or the address of a point on the XY plane or the coordinate plane or the Cartesian plane. It's all the same thing, right? So the ordered pair, and again, just stop me if anything is not clear, if I'm talking too fast or anything like that. The ordered pair A comma B has the first component A and second component B. Two ordered pairs X comma Y and A comma B are equal if and only if the corresponding components are equal. So X equals A and Y equals B, right? So then, again, the coordinates are basically the location or the address of a point on the XY plane, right? Let me see. That one, wherever it is going to have to do. So, positive X runs in this direction, positive Y runs in this direction. So if we have the ordered pair 3 comma 4, we always start at the origin, right, which is the center. The 3 tells us to go right by 3, and then the 4 tells us to go up by 4, right? So right 3, up 4, and that's the address of that point. Another thing to kind of mention, so when we draw our X, Y axes, right, it breaks the flat surface, the plane, into 4 quadrants. So quadrant 1 is everything here. Right, that's what we consider to be quadrant 1. Then it goes counterclockwise. So quadrant 2 is everything here. Right, quadrant 3 is this lower left-hand region, everything going in that direction, and quadrant 4 is the bottom right-hand. Right. Again, just stop me if anything isn't clear. Let me check the chat. Let me just kind of check some things. Okay, attendance looks pretty good. And again, I think you guys can unmute yourself. Chat. Let me see. I'm not sure what I have trouble doing. What packs points collinear, or what makes points collinear? So if you look at the word collinear, if you think about the prefix co, like co-worker, co means together or same, right? And linear means line. So the word collinear means the same line. So what that means is to show that points are collinear, if you can find the equation of the line through two of the points, and then you want to verify that that third point satisfies that equation. That's one way. There's another way, like I think triangle inequality, but I think the simplest way is, find the equation of the line through 2 points and then verify that the third point is on that line. The triangle inequality, like if you have a triangle, the sum of the two shorter legs should be greater than the longest leg, right? So using the triangle inequality, you would have to find the distance between all 3 points. In order for them to be on the same line, the sum of the two shorter legs have to be equal to the distance of the longer leg, right? So that's another way to go about it. We'll see this in action. Yeah, I'm just here, right? But let's kind of keep moving. How do I get rid of that? I think if I go like this, no. I think this one. That works for me. That's good enough. Still a little bit distracting, but that's okay. So some more definitions. Again, if anything is not clear, either use the chat or feel free to unmute yourself. My philosophy is the only dumb question is the one not asked, right? So we're here because we're all growing together. If we already knew, we wouldn't be here, right? So it's okay. This is your lab. This is the lab. This is where you get your trial and error. And let's take a moment right there. Speaking of the lab, be sure that you've sought out Dr. Lamar. If anybody has questions on how to go about the lab work, basically it's on Blackboard. When you log in on the left-hand panel, it says Online Alex Lab. You want to click on that and contact Dr. Lamar, and she'll walk you through the instructions on what you need to do there. And you basically just do whatever she says, and she's going to give me a grade that I'm going to use to log for your lab component of your overall grade. Okay. So some definitions here. We refer to the point corresponding to the order pair A comma B as the graph of the order pair. Sometimes you hear me call it the location or the address of the order pair in the coordinate system. The notation P of AB designates the point P in the coordinate plane whose X coordinate is A and whose Y coordinate is B, right? So this is the point P located at A comma B, right? Okay. So we're asked to graph the following on the XY plane. Now, I don't know if we truly have a celebrity or not. I know the student gets this a lot. As I was taking attendance, we have Will Smith. I was like, wait, what? And it could be. I've actually had celebrities in my course. I had like Chris Tucker's son, I think it was, and a few other people. But it's just really interesting. I went to school when I was at Morehouse. I came out in class of 06. I was there with Denzel Washington's son. So Denzel Washington was always at at homecoming and stuff like that. So that was always fun. My aunties was like, "Can we come to your homecoming?" I was like, "Come on, auntie." So they just wanted to see Denzel. Okay, so graph the following points, right? So for instance, say we were graphing the point A, which is 3, 1. This says basically you go on the x-axis, you go in the positive x direction by 3, and then the positive y by 1, right? So you see it here, already done. If we look at B, this says go in the negative x direction by 2 and then up by 4. So that's where B comes from. I'm gonna leave the rest of this as an exercise because I feel like you can handle it. You just have to get my attention if I need to go back through it. So now let's develop the distance formula in the coordinate plane. So recall that the Pythagorean theorem states that in a right triangle, right? This is a right triangle because we have a 90-degree angle here, right? So we have a triangle that has a 90-degree angle with a hypotenuse of length 6, C, and the legs of length A and B. Then the Pythagorean theorem, the sum of the squares of the shorter legs equals the square of the longest leg. So A squared plus B squared equals C squared, right? So now, if we have this Pythagorean theorem for a right triangle, well, what if these were 2 points on the coordinate plane? Like what if this was 1 point P on the plane that has some X, Y, and this was a second point Q that had a different X, Y, right? And suppose we wanted to find that distance between P and Q, right? So if we said A squared plus B squared equals C squared, right? I think we got it developed on the next slide. So long story short, I kind of want to draw some stuff here. So I'll do this in purple.
You're on mute, sir.
Professor Phifer.
No, that was fun. I thought you guys could hear me. I didn't know that you couldn't hear me. Okay, that was fun. I don't know. So yeah, I don't know because none of that got through. You gotta say something. Oh, it cut out. Okay, so it wasn't muted the whole time. I don't know how it got muted. That's fine. Okay, good. That makes me feel a little bit better. So at least it wasn't out the entire time. Come on. I told you my thing is being trippy. Let me see. I used a distance formula for the quiz and found the extreme level points A, B, and C. Found the distance between A. Yeah, I know. Yeah. The distance point, it can be kind of a pain. Especially when you had to do it 3 times. There are a lot of like examples where they want you to do the distance formula 3 times, but the repetition, it just helps makes it so that you can learn it that much better. So you just have to kind of like suck it up. This like the following is the reason why it's like I mean, if it were up to me, I wouldn't make everybody do this. Like math is not for everybody, right? Because you have to have patience, you have to have like a curious nature, and everybody just doesn't have that, right? And so it's, I mean, the reason we do this right now is because everybody agrees upon it. This is what everybody agrees upon. But if it were up to me, I'd be like, okay, what is it that you want to study? Let's get you started on that immediately. And then like, if you need it for what you're doing, then we would talk about it. But trying to make everybody do this, and like, honestly, it requires like anywhere from 3 to 4 hours every day of practice to get good at this, right? So whatever you practice, you're going to get good at. So, but this is what it is. It kind of allows me to kind of eat or whatever. So, I'll get this to in a moment. It's collinear. The sum of A and B did not equal the distance of AC. You said it was on the quiz. We can look at it. Audio cut out. We can't hear you. Access code. So let's see. So for Pearson, let me get this student. So for Pearson, you have to purchase the access code. There's no course ID, right? So the way you access it, you go to Blackboard. Let me get this student. You go to Blackboard and go to the assignment section and log in. And then eventually you're going to be prompted. Get this student. You're going to be prompted for payment. Okay, I got him already. So yeah, you have to purchase the access code, but there's no course ID. For the student that was on the quiz, if you can like screenshot that and like email it to me, I could pull it up, but I don't want to pull it up right now. Let me see the time. Okay, let me take a moment. I'll pull it up. Let me finish developing this idea, and then let's see if we can get to the bottom of the collinear one. Okay. So if we were to finish this one out, we wanted to find the distance between P and Q. And let me make this other note over here. So this point here, the X coordinate there is going to be X1. The Y coordinate there is going to be Y2, right? For that blue part, right? So if we say A squared plus B squared equals C squared, where A is that left-hand distance, right? So that vertical distance is going to be, what? Y2 minus Y1. And we're just gonna do like this for now. Yeah, because we're just basically substituting into a Pythagorean theorem. B is gonna be that horizontal distance. So that's gonna be X2 minus X1 squared, right? And it really should be absolute value. It's gonna, like, okay, let's develop this a little bit better. These really should be absolute values, right? Because we're doing distance. So absolute value is the distance between Y1 and Y2. Absolute value is the distance between X1 and X2. And then, right? But if we square a positive value, so then, long story short, the distance between P and Q squared equals X2 minus X1 squared plus y2 minus y1 squared, right? This is just backstory, right? All of this is just backstory. So you don't have to stress about this too much. I'm just showing you where these formulas come from. So if we have something squared equals the thing on the right, we take the square root on both sides, and that's where this comes from, right? So on your formula sheet, this is the one that you want to include. This is the final product of the distance formula. Again, this came out of the horizontal distance between x1 and x2. This came out of the vertical distance between y1 and y2. And then after we take the square root on both sides, that's where this square root comes from. Okay. So that's the distance formula. Let me take a moment. I want to see if I can pull up that question because now I'm curious. So let me hop over here. I want to stop sharing my screen for a moment. And let me see, it was a quiz. That's fine. Who was the student? Who was it? Who was it that was saying that?
Me, Mr. Fisher, Cake and Henry.
Henry?
Yes, sir.
Okay, let me see. So I think if I go to gradebook, allow, but I want to manage. I want to manage my student. Allow. Henry. Okay. And you said it was a quiz?
Yes, sir. 1.1.
Okay, let's review. Allow. Okay. Determine whether the 3 points are collinear. Are they collinear? It says that it's yes. Okay, let's give this one a go. I'm gonna pull this up. Let me see. How do I think if I go like this? There it is. It's better. Okay. So yeah, this is a good question. So I know this one pops up a lot. We're gonna go from there. Now it looks like this comes from section 1.1, question 11 out of the back of the text. Nice. Okay. And I'm gonna take this and I'm gonna just drop it right here. Okay. And let me add a page. And obviously we're not gonna have enough time to go through everything. So this is why I do like the asynchronous remote, because we're only together for like 50 minutes, right? Which is a blink, a flash. So I think all the lectures, everything is preloaded. The only thing that's not preloaded are the exams. Okay, so let me go back to sharing my screen. So we'll do the best we can together. Okay, I think the audio is fine now. Okay. So we have this question, it asks us to determine whether the 3 points are collinear, right? So let's give it a go. So we see that the result should be yes, so right? So let's start with using the distance formula, right? So the distance formula. The distance between 2 points, P and Q, is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared, right? And it's the square root of all of that, right? So we have these points. We have 0, -4. We have -3, -19, and we have 2, 6, right? Now, I feel like the distance formula is the harder way to do it, but let's go ahead and do that just to do a demo. So now I'm a fan, whenever I have ordered pairs, I like to just automatically label them. I'm gonna go x1, y1. I'm gonna go x2, y2, and I'm just gonna go ahead and label this one x3, y3, right? The subscripts just mean 0.1, 0.2, 0.3. Okay. So, I'm going to label the first one as the first distance. It's going to be the square root. Now I'm going to say my x2 minus x1. So that's going to be -3 minus 0 squared plus -19 minus a -4, right? So you have to be cognizant of your use of parentheses. It's very easy to lose track of the signs here. So this first one, -3 minus 0 is -3. -3 times -3, -3 squared is going to be what? +9. So then that's going to be the square root of 9. Now here, double negative is positive, so that becomes a negative 15. Negative 15 squared, I think, is 225. Hey, Siri, what's 15 times 15? Yeah, 225. So this is going to be 225. So then that one, 235, so 234. All right, and I'm gonna just leave it like that for now. So then the second distance, I'm just gonna do the first and the last. So xy, xy. So then it's gonna be 2 minus 0 squared plus 6 minus a negative 4 squared. So notice my use of parentheses to keep track of my signs. Let's go ahead and add another page. Okay. So then 2 squared is 4 plus double negative becomes a positive. All right. So then 6 plus 4 is 10 squared is 100. Okay. So then that one is 104. Let's see. So it might need to be a squared plus b squared equals c squared. If they're equal, so we got, let's test the third distance. D3, they should be equal. Let's keep going. So then the third one, we said the first and second, first and last. So then we got to do the second and last. So then I'm going to say 2 minus a negative 3 squared plus 6 minus a negative 19 squared. And we're taking the square root of all of that. Okay. What is that? 5. So that's a 25. 25. So that's 100. No, that's 50. 50 squared, right? Wait. That's 25. Hang on. 25 squared is 625. Did I make a mistake somewhere? Hang on. 625. So that's 650. Right? So it does look like it's a no. Did we miss something? 0, negative 4? Did we make a mistake somewhere? Okay. 2 and 6. 2, 6. So let me check one other thing. Let me try one other thing. Because that does look like it. Based on that, it's like it's a no. Because that adds up to what? 334? So let's check one other technique. I'm going to use the y equals mx plus b. I'm gonna find the equation of the line through 2 of the points and then verify the third point. All right. So for instance, when x is 0, so we know that b is negative 4. If I made a mistake, you have to bring it to my attention. Otherwise, we got to get to the bottom of it. So then let me see x and y. So then when we plug in 6, 2m. Let me see it back up. Our x is what, 2? Yeah. So 2m minus 4. So that's a 10. So the m is 5. So then our claim is that y equals 5x minus 4. Okay. So let's see if this works in the 2, and let's see if it works in the 3. In the third one. Determine where the 3 points are collinear, right? So when x is 0, the first one checks out. All right. This one checks out. Let's go ahead and test the other one that we use, the 2 and the 6. When x is 2, 10 minus 4, this one checks out. Right? So then all we need to do, let's see if this last one works. When x is negative 3, yeah. So that one worked. So why is the distance formula not working? Do we need to find those distances? Maybe they do work. Hey Siri, what's the square root of 234?
The square root of 234 is approximately 15.297.
Now this one, 15.297. Hey Siri, what's the square root of 104?
The square root of 104 is approximately 10.198.
198. Okay. Hey Siri, what's the square root of 650?
The square root of 650 is approximately 25.495.
25. Yeah, I think they actually are equal. So, right, we just was interpreting incorrectly. So if you say this plus this, it looks like it's this. So I think what we had before was correct. We just don't need the squared. For the collinear, the sum of the two shorter legs should equal the length of the longer leg. So A plus B should equal C, just lose the square, right? And so before giving up on it, I was like, well, let's verify it with something that we're more familiar with, right? And so this one checked out when we did, so we just had to augment our theorem, right? Because I think we said A squared plus B squared equals C squared, but then we just needed actually the sum of the lengths. So just A plus B should equal C, right? That was a change that we had to make. So we got to the bottom of it. I think these added up and they worked out. That was actually a really good question. I enjoyed that. Okay, so we are essentially out of time. Did you guys want to did you have another question from something before? Because that was actually a really good one. I like that one. And like I was saying, like this is an example where the distance formula is a pain, and you just have to, hopefully the other technique, will work for you, right? Sometimes the distance formula is unavoidable, but but then sometimes you just have to, like, there's nothing you can undo. You just kind of have to suck it up. Did it go that far back? I didn't want to go that far back. Redo. Okay, let me check the chat really quickly. That was a good question. Yeah, so I think we did just make a mistake on, it shouldn't, for the collinear, it shouldn't be A squared plus B squared equals C squared. It should be A plus B equals C for collinear. All right, delete. So that one was good. Okay, so let me check the chat real quick. Because I noticed someone was trying to get my attention, but then they kind of like stopped. Yeah, it's no worries. Yep, okay, good. Cool. And we fixed that. Cool. Okay, let me look at one other thing since we're here. And I want to keep you for about 5 more minutes, no more than 5 minutes. So let me do the following since we already have it up. So I saw that, I think he got the other one straightened out, but let me see this other one. Without sketching a graph, find the x-intercepts. So I did have a student ask this question over the weekend. So I'm going to take some time to go ahead and do this one as well. Because I know someone, because I think I did a video reply, but this is a good time to kind of go through this. Here's a copy. Just want to drop it right here. And let's add a page. Okay, and this guy right here. So let's just take a moment. This shouldn't take that long. We should be able to get out of here on time. Come on, screen. Start. Okay. All right. So someone did have a question over on this one. Now, this is why it's important to be subscribed to my YouTube with your notifications turned on. I did a video response to this one already, but since we're here and we have a few minutes, I do want to take a moment to just look at this one because someone did ask about this one. It says, without sketching a graph, find the x-intercepts and y-intercepts of the graph of the equation. All right. So the intercepts. So for instance, So we want to find, I encourage people to start with the y-intercept first. That's oftentimes easier than the x. And to find the y-intercept, that's where the graph crosses the y-axis. So what we do there is we want to set x equal to 0 because x is always 0 on the y-axis. Right? So then if we set x equal to 0, we're going to get y equals 0 squared minus 3 times 0 minus 10, right? So then you should quickly see that this goes to 0, this term goes to 0. And I think we're left with negative 10 there. Okay. Style. So then it's a similar dialogue for, if that's the y-intercept, it's similar for the x-intercept, right? So we want to set, y is always 0 on the x-axis. So we want to set y equal to 0. So if we set y to 0, and this brings me to the point that I wanted to make, x squared minus 3x minus 10 equals to 0. So for this course, it is expected that you all have some command of factoring, right? Now, I think as professors, we do acknowledge that even though we expect you to have a command of factoring, we do acknowledge that many people do not. So that's why we have things like the lab to kind of give you some additional practice on factoring. There's also a handout on my Blackboard that gives you an overview of how to approach a factoring problem. So, but this is like the second case where you have a trinomial, you have 3 terms. And in this case, we can actually jump straight to this form because this leading coefficient here is a 1. So because there's a 1, if it's factorable with integers, we can jump straight to this form. So then we can say x and x. So we're looking for 2 numbers that multiply to give us negative 10 and add to give us negative 3, right? So this sign tells us that the signs are opposite. This one says that the larger one is negative. Let's do that one more time. The second sign tells us that our signs are opposite. One has to be positive, one has to be negative. This first sign tells us that the larger number is negative in this case, right? So it looks like our 2 numbers are going to be negative 5 and what? Positive 2, because negative 5 times positive 2 is 10. Negative 5 plus negative 2 is a negative 3, right? So then from this point, we use a technique called the 0 factor property. When 2 or more things multiply to give us 0, basically we set each factor to 0 and solve. So we're going to say x minus 5 equals 0. And another solution is going to come from x plus 2 equals 0. So then if you solve each of those corresponding equations, here we get x equals 5. Here we get x equals negative 2. And we got these results. This is for the x-intercept, right? So these are the x values. Come on. Hang on, give me a second. I'm about to... Now, I know the text oftentimes does it like this, right? Instead of the ordered pair. And a lot of it, once you have your answer, when it comes to Pearson, a lot of it is like follow the instructions and put it in whatever form they want, right? So we're saying that if we plug in negative 2 or 5, we should get 0. So quick check. This is going to be a 4 plus 6 minus 10 is indeed 0. So the negative 2 checks out. When we plug in 5, we get 25 minus 15 minus 10, which is indeed 0, right? So both of these x values generate 0, right? So I think those are okay. I'm going to let that be the extent of my checking. Are there any other burning questions before we go our separate ways? One thing I have noticed. Hang on. So one thing I noticed is that, like, I know I loaded the student notes, right? And so that means you don't have a copy of my instructor notes. If you want like complete notes, like, because there's a lot of details that are omitted, You can either comb through the video, or if you need the PDF, just let me know and I'll make it available. Let me check the chat really quickly again. I think the chat looks good. We don't have any stragglers. Okay. So if there aren't any burning questions, go ahead.
Where can I find the YouTube? Because I don't have it right now.
Okay. So for YouTube, let's see if we go. Let's go here to the portal. Let's log into Blackboard. So if I go to Blackboard, and you all are right here, come on. So when we log into our course, it should look like this. If you say YouTube, so you click here, when you open up this folder, it's the last item, number 5.
All right, thank you.
That'll take you. Any other burning questions before we go our separate ways? Okay.
You
If there
said
aren't
you
any
were
burning questions, we're going to end the session here. Go ahead. Can you hear me?
hello?
Can you hear me?
Yeah.
Yeah, go ahead.
You said we would go over the if you didn't get checked in or marked attendance for last week's class.
Yeah, let me see if I can pull that up. So let's see. I think we're done for today. I guess I need to send. Okay, pretty good attendance overall. And this is. What's your last name?
Mott.
Mott? Okay.
Yes.
Let me see. So for right now, I don't mind going back because I know it was the first day. And I think it would just be simple to just give people credit. Oops, present.
I was under Zoom user last time.
Oh, Zoom user.
Could you do the same thing for me too? I came late. I was there though.
They're letting me today. Oh, that's today. Hang on, Mr. I'll change this. Okay, who was the additional?
Thank you.
Me, I'm Devin Fosu.
I saw where I saw where you popped in, Mr. Fosu, last time, so you already got you.
Oh, okay. Thank you. Can I email you if I have any questions?
Of course.
Okay.
As a disclaimer, though, I am a little bit bad about responding to emails, but send it anyway.
Okay.
Send it
That's
anyway.
fine.
Get to it by the time we meet again. Just ask me in the next class.
All right. Yeah, that's fine.
Any other questions, gentlemen? Going once, going twice.
Oh yeah.
Hold your P's and Rights. Okay.
Send an email as well. If you can get back to me soon.
Does it need to? Can we talk about it now? Does it need to be private or?
I mean, we can talk about it now. It's gonna be lengthy. I did include like the screenshots. It was just about my question number 5.
Question.
Yeah, I did get it right. It's just that the Pearson wanted it in integer form. I put it in like in an order pair.
Yeah, it's a quiz, right?
Yeah,
Just
it's the
do
same. It's just
only
like
fractions. And like doing that repetition is going to serve you. Like you'll just know it that much better.
okay.
Yeah. Just redo that one because what you're saying is correct, and there's nothing wrong with it, but it won't hurt you to just do it again.
Okay, cool.
Okay. Was it just that one question?
It was just that one. Thank you.
Yeah. Okay. Yeah, it's minimal points. It's not going to get in his way. Okay. Anyone else for once? Going twice? Everybody hold your P's and Rights. Okay. All right. So, we had a little bit of hiccups. That shows me what I need to go back and update. I need to go ahead and redo you guys, do some instructor notes for you guys. I thought I did it, but I guess I hadn't. Yeah, otherwise, just kind of keep working. So next class, what we'll do, we'll work on section 1.2, right? All right, so on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.
You as well. Have a good day.
Thank you.
Thank you, Professor.
Thank you.
Thank you. Have a nice day.
You as well. All right, all right.